Today we're looking at horizontal asymptotes of rational functions. So there are three cases when it comes to horizontal asymptotes. So we're going to look at three different functions that illustrate those three cases. We're going to start off with f of x, and what we're going to do is find the degree of the numerator and the degree of the denominator. Now the degree of the denominator we know is 1. So on the side here I'm going to say that the degree is equal to 1. Now the numerator is constant. We can even think about this as being x to the 0, but the degree in the numerator is going to be 0, and I'm going to call that m. So here we have a case where the degree of the numerator is smaller than the degree of the denominator. Now when that happens, our horizontal asymptote is going to be the x-axis, y equals 0. So I'm going to enlarge our little graph here, and we can see that we've got a horizontal asymptote right along that x-axis. So as our x values get infinitely large, our function's getting closer to the x-axis. Same thing from the other direction. As x goes to negative infinity, our function is getting closer and closer to the x-axis. So here is our second case. We're looking at a new function g of x. The degree of the numerator is 3, and the degree of the denominator is 3. Now here's a situation where the degrees are equal. When that happens, the horizontal asymptote is going to be the ratio of the leading coefficients. So the leading coefficient in the numerator is 1, and in the denominator the leading coefficient is 2. So we should have a horizontal asymptote at y equals 1/2. So let's look at our graph, and I already drew in the asymptote. So it's this line here in red at y equals 1/2, and as our function, or as x goes to infinity, our function's getting closer and closer to 1/2. Same thing from the other direction. As x is going to negative infinity, our function is getting closer and closer to 1/2. And here's our third and final case. We've got the degree of the numerator is 4, the degree of the denominator is 1. Here the degree of the numerator is larger than the degree of the denominator. When that happens, we will have no horizontal asymptotes. And we can see that from our picture, that there's no y value that our function is getting closer and closer to, no horizontal asymptotes. So here we have three different functions. We're going to find the horizontal asymptote of each. For the first one, we see that the degree of the numerator is 5 and the denominator is 5. Since the degrees are equal, our horizontal asymptote will be the ratio of the leading coefficients, so it's going to be just 2/3. Second function, the degree in the numerator is larger than the degree of the denominator, so this doesn't have any horizontal asymptotes. And then our last one, the degree of the numerator is 1, which is smaller than the degree of the denominator, so the horizontal asymptote will be y equals 0. And here is our summary of our three cases. If we're looking for horizontal asymptotes, if the degree of the denominator is larger, then the horizontal asymptote is going to be the x-axis, whose equation is y equals 0. If the degree of the numerator and the denominator are equal, then the horizontal asymptote, we don't need that s there, is the ratio of the leading coefficient. And finally, if the degree of the numerator is larger, then we won't have any horizontal asymptotes at all.